My name is Wilkistar Otieno. I should say mi nombre Wilkistar Otieno, and that's the much Spanish I know. It's a pleasure to be here at the University of Talca. This one? Okay. I want to thank all the faculty of the university for the invitation, the Office of Technology Transfer, as well as really Francisco Maturana for the invitation that he gave me, and also because of the partnership that we have had. Today, I will not talk about the success of the partnership with Francisco's company, Rockwell Automation. Instead, I will talk about the something that we have at the University of Wisconsin-Milwaukee. We call the Industry Assessment Center. And this center is funded by the US Department of Energy. But before I get into that, I wanted to just say a little bit about me. My journey began in Kenya. I had my bachelor's of mechanical and production engineering at Moi University. And that's the picture of the administration building in Kenya, in a city called Eldoret, which is about 300 kilometers from Nairobi. And then from there, I moved to Tampa, Florida. I did my master's as well as my doctorate there. And I had the privilege of having 3 friends from Chile, 2 from Santiago, 1 from Temuco. And so it's wonderful to see where they're from. So thank you so much for making that possible. After graduating from industrial engineering in Tampa, Florida, I moved on to University of Wisconsin-Milwaukee. University of Wisconsin is a big system. We have about 10 campuses. Right now, they're trying to consolidate because of budget. We are the second largest. The bigger one is called University of Wisconsin-Madison. And so I joined the industrial and manufacturing engineering department. I got my associate professorship about 3 years ago. And in 2018, I went on sabbatical. I don't know if in Chile faculty go on sabbatical, yes? So my sabbatical was quite successful, I would say, and it would not have been possible if it were not for Rockwell Automation. I think maybe I was the first faculty to take a sabbatical in Rockwell with an office inside of Rockwell Automation. And in addition to that, 2 of my PhD students were able to work on research inside of the company, which is good because they are able to interact with the company personnel. And actually, for one of my PhD students, Francisco was part of the committee, and he was able to communicate with him even a lot more than I, because he was able to get access to the Rockwell Automation data, Rockwell Automation equipment, Rockwell Automation resource, and that makes for a very good partnership. My focus of research is sustainable manufacturing, particularly remanufacturing, which right now a lot of companies have to determine, the circular economy. You produce something, where does it go? Do you take it back? Who brings it back to you? And what do you do with it? I think in countries like Denmark, you cannot replace a fridge maybe in 1 year, because where do you take it? So that's the first research area. The second is advanced manufacturing, connected enterprise. Francisco talked about it as part of the application they're doing in defect detection. And then I have a passion for engineering education. Particularly, I have an NSF grant for a scholarship for undergraduate students, and mostly to increase the number of women in engineering, which I think all of us know that is still a low percentage. So that's about me. I like to work with students, so these are a few of the organizations that I advise. The IEEE, I think the person who spoke in the morning, I saw he has an email of IEEE. So I work with IEEE, I work with Society of Women Engineers, as well as we have an exchange program with a university in Taiwan. So I like to work with students. This is just an aerial view of Milwaukee. It gets very cold. And as you can see at the horizon is Lake Michigan. So I just wanted to show you where we are from, and Francisco would be beyond that lake in Ohio. Thank you. So the agenda today, I'll try to be very fast so that we can save on a little bit of time. I'll talk about this Industrial Assessment Center, and particularly the one we have in Wisconsin, Milwaukee, and then a little bit of the statistics of what we found out from the small, medium enterprises with regards to energy usage. So what is the Industrial Assessment Center? Back in 1976, I believe, the Department of Energy, and particularly the Office of Energy Efficiency and Renewable Energies, decided to start what we call industrial assessment centers. What industrial assessment centers are is centers that are located inside of universities, but the faculty and the students go to small and medium-sized companies to do energy assessment. The reason is big companies like Rockwell Automation have energy engineers in-house. The small and medium-sized companies are sometimes small. They either lack the manpower or sometimes even the resource to have an energy office. And so we go in there and talk to them, and I'll show you the makeup of our assessment center in terms of the people. And as you can see, we are one of, right now, 29 such centers. It's a huge grant, about $3 million for 5 years, or maybe 6 if you have an extension. The main program is in Rutgers, in New Jersey. So all of these programs must report to Rutgers, and Rutgers is the one that manages the database. So I will talk to you about the process that we go through when we are doing the energy assessment. Why is this important? This one I already talked about. The first ISC was started in 1976, about 42 years ago. And I think the length of time sort of indicates the success. Otherwise, they wouldn't fund so many universities. Why is it important for Wisconsin? I would say that we are located in one of the highest concentration of manufacturing companies, and especially the small and medium size in the US. And that's why it's most important for us. We usually do, maybe I should say, we are mandated to do assessments in about 150 radius of the university. But sometimes we go far away. For example, 2 weeks ago, I was in a company right here, really about 1 hour to Duluth, somewhere right here. And we went there with a few students. I'll show you a picture later on. We're the only ones in Wisconsin right now. As I say, we are funded by the Department of Energy. The companies do not pay at all for this to be done. However, they have to be willing for us to go disturb them for a day. They have to be willing to give us their data, particularly energy usage, gas usage, water usage, and the bills as well, so that we can see where are they spending the most. Our focus is improve energy efficiency, reduce wastage and pollution, as well as increase productivity. And this links well with what Francisco talked about, because even though their goal is not directly to save energy, they're indirectly saving energy by increasing productivity and reducing waste. Again, small, medium, especially the ones that are located 150 miles from our campus. This is the criteria of what makes of a small, medium enterprise that we go to. Gross annual sales should be less than 100 million, fewer than 500 employees. That's the definition of small, medium size. And as you can see, the rest of the requirements. This is a code for different companies, so specific to manufacturing. But right now we are enlarging and going to wastewater management. You know, like I don't know in Talca if this is owned by the government, but in our location, they are owned by the municipality. So Milwaukee has the Milwaukee Wastewater Management. We go there and see how the energy usage is. Besides just the campus, we work with, shall I say, organizations that are focused on energy sustainability. So for example, Focus on Energy is one of them. The Office of Energy Innovation is the second one, and you can see all of these. The lower one, Wisconsin Energy, We Energies, is the energy provider for our location. Franklin Energy is the energy provider for maybe about 30 miles south of Milwaukee. And then this is something new, Midwest Energy Research Consortium brings together industry and universities, researchers to work together on mutual benefits. So we do thank this strong partnership that we have. It enables growth, it enables success. As you can already tell, the Industrial Assessment Center kind of brings together industry, faculty, and students. The faculty is able to connect with industry because we see what are the needs of the industry. And we are able to bring our basic research to apply to something that's real, which to me is most important than to work on basic research, which will have usage 10 years later, but 10 years later, the industry has already moved. So it's really good to have that close relationship with the industry so that we are working on issues now that need to be solved. When we are working with our students, we are able to link theory to practice, enrich classroom experience, and also actually give students a job because they don't do this for free. Some of them are research assistants, some of them are paid by the hour. So it's a mix of advantages. And I would say this here is really good because if today you graduate from this ISC, this report here is free. Any of you can go in and see. They tell the percentage of PhD students who have found job as energy engineers at the company, which never used to be the case. So I think this is good, especially for the industry today, because now they're able to get workforce that is ready to do the energy assessment in their companies. So when it comes to Wisconsin-Milwaukee, this is the makeup. I'm not the director, I'm one of the assistant director. The director is Rio Amano, a mechanical engineer. Pradeep Rohatgi, materials engineer. I'm an industrial engineer. Lin Fen Wang is an electrical engineer. And the reason why he joined is because Department of Energy is now interested to see how cybersecurity is being done at the industry. Francisco talked about industry, Internet of Things, and so we go in there. It's not my expertise. Lin Fen Wang and one of our PhD students, Rafat, he's my PhD student, they go in there and see how secure are the control drives, for example. Right now, machines and to-machine communication is enabled by the internet or the Ethernet. So they go in there and see how the cybersecurity has been implemented. And then as you can see, mostly the students are mechanical engineer because the director is mechanical engineer. And so a lot of them are working with him on research. And particularly wind energy and gas turbines. So what happens during the assessment? We have a meeting with the personnel. This one normally happens between the faculty and the company for introduction, to say who we are and what advantages we can bring to them. And then second, we request for data from the company, bills, energy usage. Sometimes, if they're able to, they give us how many motors do they have, the consumption of the motors, how many shifts do they run, how many people. After that, we understand the manufacturing process. Actually, between data collection, we have a meeting at the university, and then we attend the plant, okay? So understanding the manufacturing process can either happen before we go to the plant or when we get to the plant. And then, of course, we are given a very detailed plant tour. Normally it takes 2 to 2.5 hours. And then, of course, we have several data collection points, even, digital data collection using cameras. We have a meeting over lunchtime. It's a working meeting. Students and faculty and the company talk about potential areas of saving or improvement. And then sometimes we need more data collection. And then finally, we have a closing meeting before we go. Usually, after 60 days, we have to give the company a very detailed report of all of this information. What we understood from their bills, how much energy they're using, the potential places they could have a saving. We even do a return on investment calculation from our perspective. Of course, theirs would be different. And then I told you about the focus of energy. Focus on energy. When we go to any company visit, we go with a person from Focus on Energy. The reason, for example, if you implement any renewable energy sources, or if you change your lighting to LED, Focus of Energy gives the company a rebate. So when we go with somebody from Focus of Energy, they are able to answer any questions right there. And of course, it gives us legitimacy. When Focus of Energy is among the team, then the company says, yes, I think you're legitimate. And when 60 days are done, the same report we have to submit to Department of Energy. And they're very, 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 it's a critical time period. We dare not miss that deadline of 60 days. It's something that they usually follow up to determine which center is successful, which one is not successful, to make sure that we do that. And then Department of Energy will contact the company to not only ask how we did as a center, but also ask the company, okay, given all these recommendations, how many have you implemented? The PDF that I showed you has data about what has been implemented, I think up to 2017. That PDF you can look at. And support that we need from the company, I already talked about this, being able to access their utility bills, having a contact person that we can talk to, and also, feedback to the national IAC, like I talked to you about, to make sure that they're able to say if they were able to implement, how much it cost them to implement, and all that. I'll show you 2 examples of energy bills. Out of so many, we have done about 200 such assessments. The first one on this side is the company that we went 2 weeks ago. It's a semiconductor company. They actually are producing the control panels as well. And then this one here is actually a wastewater management plant. So you can actually tell how different the utilities are. Yeah. This one here is mostly because of heat. heating the facility. Wastewater management plan ran 24 hours, 7 days a week, 365 days a year. The utility, I think they only do 2 shifts, and so they don't have to do a lot of heating. So that's one of the examples. But what we are mostly interested in is companies that, if you look at this bill right here, average on-peak electricity cost is nearly double the average off-peak electricity cost. I don't know if this happens in Chile, because the US market is deregulated. So the cost of energy between 6 p.m. and 6 a.m. is nearly double. 6 a.m. to 6 p.m. is nearly double 6 p.m. to 6 a.m. at night. So it's a plane here. In Kenya, it's also very flat. But in the US, it really matters, because now we look at their system and see, okay, so what equipment can be run at night, and then whatever is being produced, they can have an energy saving instead of running it in the daytime. But again, not all companies can do that, so energy saving can be in different forms. And this is like to show you, I think this one was the water treatment, and you can see how much on peak. On peak is the green, blue, off peak is the red. So if, as much as possible, if they can increase the off peak production, that saves them quite a bit. So there are several analyses that we have to do before we go to the company, right? The next slide I have here just shows, a little bit of a peak of 16 foundry companies that we visited. The first column is companies, number 1 to 8. I only have 8, but we have 16. And then this is their energy bill, the total savings given our recommendation, the implementation costs, and then, of course, the payback period and the saving that they get. So this is just an example, and I think it's been successful, and that's why we were funded for a second time. This is just an example. The meaning of AR is assessment recommendation. And I know we have several electrical engineers in the house, so you really can see the different recommendations that we have. And most of the recommendations are usually in the combustion system, as well as the thermal system, HVAC, compressor, even motors. You'll be surprised how many companies do not have the variable frequency drives. Yes, so many companies don't, and so we go in there and tell them and it costs a lot to change, from the fixed to the variable frequency, but we let them see the payback period, and some of them are able to do it. So this is a sample of a report that we were able to give with a payback period of a half a year. An example that I have here, which is very common, especially for companies that have a furnace, the exhaust is usually quite hot. Yeah. And so even as something as simple as installing that thermal interchange so that it can preheat the heat that goes, preheat the air that goes into the furnace, has a very good payback as well. The second one, which is also very common for companies that have boiler units, just the insulation by itself, right? Because we have the torches that are able to see how much temperature it is in every part of the furnace or the boiler. So even just as simple as the insulation is usually of energy saving. I told you the number of companies. We have to meet the target of 20 companies every year. It's usually a bit difficult to do that. But I wanted to share with you just a little bit of the companies that have the most energy usage. And this one actually tells you that the chemical and the paper industry, metal industry, have the highest energy usage. Paper, because we are located in Wisconsin, there are quite a number of paper companies there. All right? And then considering considering the amount of recommendations that we usually give the companies, and this is really not for Wisconsin alone. This is data from the entire ISC program in the whole country. Most of the recommendations are about energy management, nearly 90%. And what you cannot read probably at the back, this is the combustion system, that's the thermal system. They have more than 50% of the recommendation. And so the success of such a project really will require both industry, government, and university partnership. This was just the process that went into filtering data that we used for the analysis, just to say that we took away the outliers. So for example, we only took where the electricity price is less than $0.5 per kilowatt hour, when the gas price is less than 50, payback period is less than 10 years, because of course 10 years would be a lot more, and so on. And then outliers, of course, were removed. But I wanted to share just a few. This one here just tells us that, for example, the food, the textile, and the wood have the least efficiency, and that translates into opportunity. Yes, it translates into opportunity, but the efficiency is between 60 and 80%, as at, actually 80 to 90% as at now, not 60. And then here is another radar plot. The first one is considering, it factors in the number of employees. So considering the number of employees, it talks about improvement ratio. Again, we have wood that has a lot of improvement that could be done, but mostly non-metallic, mineral, plastics, and chemical. Lots of improvement could be done considering the number of employees that are in that facility. This one is considering square footage. Again, most improvement could be done. Most improvement could be done with the mineral and plastics as well. And then here, it also talks about improvement with respect to electricity usage, improvement potential with respect to gas usage. So some of this, and this was analysis that was done again from the data countrywide. And then finally, I just want to show you when we go there, we have official gear. We go there as you know, representing the university, but also abiding by the rules of that place. And then this was the company that we went 2 weeks ago, which manufactures semiconductors. Yeah. So that's all. Thank you so much. If there's any question, let me know.
We have time for one question.